The Heisenberg uncertainty principle. To explain the Heisenberg uncertainty principle, one must first understand that all objects in quantum mechanics have both particle and wave properties. This means that they do not only have a certain position and a certain momentum, but also a certain wavelength and a certain frequency. The Heisenberg uncertainty principle states that two complementary quantities of a quantum object cannot be determined simultaneously with exact precision. This means that the more precisely one knows the position of a particle, the more uncertain its momentum becomes, and vice versa. This is because the wavelength and the frequency of a particle are related to each other. The shorter the wavelength is, the higher the frequency is, and vice versa. The Heisenberg uncertainty principle can be illustrated by a simple wave. If the wave is very stretched out, one can determine its position well, but its frequency is very uncertain. If the wave is very short, one can determine its frequency well, but its position is very uncertain. The Heisenberg uncertainty principle expresses this uncertainty mathematically. The Heisenberg uncertainty principle has far-reaching consequences for quantum physics. It shows that there is no absolute reality, but only a probability distribution of possible measurement results. It also shows that there is no sharp boundary between observer and observed, but that every measurement affects the quantum system. A holographic universe is a hypothetical theory that states that our three-dimensional space is actually a two-dimensional projection of a higher dimensional reality. This means that all information about our universe is stored on a kind of cosmic hologram that lies at the boundary of observable space. A possible connection between the Heisenberg uncertainty principle and the holographic universe is that both theories suggest that our perception of space and time is not absolute, but depends on our perspective. Moreover, the Heisenberg uncertainty principle could explain why the holographic principle holds. The smaller the space in which we want to store information, the more energy we need for it, and vice versa.